By now, we should understand the logic gate function, like what we did in our previous video. If you don't understand how the logic gate works, do check this video out, links in the description box. So we are going to be using one of the logic gates to design a memory circuit known as the SRO latch. The SRO latch is a sequential circuit that is used in digital logic and in electronics. The SRO has two stable states and can store a single bit of information. The two stable states are known as set and reset. The SRO latch also provides two outputs, namely Q and bar Q. A latch is a simple digital circuit where the outputs can be set to either a logic 1 or a logic 0 by an input signal. The circuit then remains in or remembers this state even after the input is removed. So let's see how this works and design one. Let's take an example of an OR gate. We all know that the OR gate output is only high if there is any high input, but any both low input will keep the output low. But what if I feed back that output back to one of its inputs, and let's see what happens. When we take the first input high, and now we get a high output, and that high output is being fed to the second input. So both inputs are already kept high, and that changes nothing, because even with both inputs high, an OR gate still give an high output. But now, what if I take this input low? Does that change anything? And you can see this circuit supposed to go off, but got latched. This is a result of the holding high output at this input. But the problem with this circuit is that this state remains here forever until power is being disconnected from the circuit. But that's too obvious. It should be just simple. But what we are trying to understand is known as the sequential circuit, which implies that its output relies or depends on its present input signal and previous output. This previous output becomes in form of the present state, and this is done by storing its previous input signal. Now, to design a SRO latch, we need two NOR gates where the output of one will be fed into the input of the other. We could see at the output of both NOR gates we have an high output, because the NOR gate output is only high with both inputs being low, but any high input, its output would go low. So let's see what changes if I feed in the high output signal of the first NOR gate into the input of the second NOR gate. Now the second NOR gate has resulted to an low output because it now has a high input signal from the output of the first NOR gate. So now by feeding its low output into the first NOR gate input, we see that nothing changes for the first NOR gate. Why? Because the second NOR gate output is already low, so its both inputs are now already low. That's why our high output still remains. So our first input switch will be our reset, and our second output switch is our set. Looking from the SRO latch truth table, we could use this to see what happens if any of the switches goes high. The first NOR gate output is our Q output, and the second output is our Q bar or bar Q, means it is the complement of the output Q. If Q is 1, then bar Q will be 0, and if Q is 0, bar Q will be 1. When S and R are low, the resulting state is invalid, which means it could either be that Q or bar Q will be high, according to whichever turns on first before the other when power is set. Okay, let's see the next action. S, which is set to low, while reset goes high, and we could see bar Q comes on. But why did it change? It's because now we have taken the first NOR gate input high. This results as turning its output low, and the second NOR gate input is now low, leaving its output high. That high output is fed into the input of the first NOR gate. Now the circuit latches and remains at this position. Even if I had to turn off the switch and still turn it on, it changes nothing because it now depends on its previous actions, since this high signal is still at its input. The next action is the set. So we set the input high and now its output Q is high while bar Q is now low, and the circuit latches again, coming to a new state since its output is now low and fed into the input of the first NOR gate. So that results to a high output. But if we take the both input high, this takes the two gate input high, resulting to a low output, and that's how an SRO latch circuit works. And also, this was an example of my practicalized circuit of my work on a breadboard, and the circuit worked out well. Well, if this video was helpful, please don't forget to like, subscribe, share and leave a comment about what you understand. And also, let me know where you're watching from, and see you next time.